let me now show you a different way of classifying, a more so this is a frequentist approach. Let us use a Bayesian approach. And in the Bayesian approach, what we assume is that when we get data like that, we can form a likelihood function, and from the data we can also formulate a prior. So if based on that, we can then compute the Bayes probability, the posterior probability. And the point is to show you simple ideas about that with regard to what the shape of the function looks like, the posterior probability, and also what the uncertainty about your classification looks like when the variances are equal or unequal. And so let's do some examples of this to get a sense of it. So Bayes classification. So our data is labeled, comes as follows: x1, y1, well, this is a vector where y belongs to some class, 0 or 1. Let's write it as a set. So when we formulate the problem as a Bayes classification, what we have is a probability of having our class y being equal to, say, class 1, given that we have some x, and that's of course the probability distribution of x given that I'm class 1 times the prior probability of being in class 1 divided by the marginal, which is just the probability of x. And this probability of x is going to be equal to the sum of the two probabilities associated with probability of x given that y is equal to 1 times the probability of y is equal to 1 plus the probability of x given that y is equal to 0 times the probability of y equal to 0. So this is the marginal, this is our likelihood, this is our prior. Okay, all right, so let's do a simple classification. Suppose that my data set is height. So we have some height of individuals, and we want to classify them as being male or female. So, maybe I'm going to say 0 and 1 represents our female and male representation. So if it's class this, if it's 1, we're going to call it the male. And so let's begin with our likelihood. So maybe probability of x given that you are male. So here's height. And you have probability of particular height given that you're a male. Maybe it looks like this. And then you also have probability of height given that you're a female. And the mean is going to be, as we know, something smaller. And if the two variances are equal, so suppose that the two variances of our likelihood function are equal, then what's going to happen is that these are my probability of x given that y is equal to 1, probability of x given that y is equal to 0. So what am I doing? I'm multiplying this times the prior probability. So say that I have equal likelihood of having a male and a female. So this just gets multiplied by some number, 0.5 in this case. And then what I'm going to do is that divide it by this quantity here, which is probability of y given x. Well, this is just the sum of these two things times the prior probability. So the p of x is going to look like something like this. Right? This is sum of those two multiplied by the prior probabilities. All right. So now if I divide this quantity by this, what I'm going to get I take this red one and divide it by this blue down here, I'm going to get a function that looks like this. If I take the blue and divide it by this, I'm going to get a function that looks like this. And this is now the probability of male given a particular height. And you notice that the place where these two cross, this is your decision boundary, where these two lines cross, this is going to become your decision boundary, and this decision boundary is going to be the same place as this. And so in principle, what you want to know, your decision boundary is where the ratio of the probability of x given y is equal to 0 times the prior probability of y is equal to 0 this is the location where this is equal to 1. And the numerator and denominator are equal to each other in this case. That's your decision boundary. I don't know where I am. On the other hand, if the numerator is bigger than the denominator, then I'm going to be in class 0. If the denominator is bigger than the numerator, then I'm going to be in class 1. My decision boundary is when those two probabilities are the same. So that's pretty simple. Now, let's not consider a condition where the variances are unequal. Do you have any questions about this so far? All right, that's pretty